తెలుగులోనే ఆర్గనైజ్ చేయాలి కాబట్టి ఈ వెబినార్ లెక్చర్స్ అన్నీ కూడా వీలైనంత వరకు మేము తెలుగులోనే ఆర్గనైజ్ చేస్తున్నాం. ఈ స్కోప్ అనే ప్రాజెక్టు సైన్స్ కమ్యూనికేషన్ పాపులరైజేషన్ అండ్ ఎక్స్టెన్షన్. ఈ ప్రాజెక్టు విజ్ఞాన్ ప్రసార్ డిఎస్టి ద్వారా ఎన్ఐటి వరంగల్కు శాంక్షన్ చేశారు. ఇది 2021 ఆగస్టు నుండి స్టార్ట్ అయింది. ఈ ప్రాజెక్టుకు అవర్ బిలవడ్ డైరెక్టర్ ప్రొఫెసర్ ఎన్వి రామారావు గారు చైర్మన్ గారు ఉన్నారు. ఐఐసిటి డైరెక్టర్ డాక్టర్ శ్రీనివాసరెడ్డి గారు కో చైర్మన్గా ఉండి దేర్ ఇస్ ఎ కోర్ కమిటీ ఇన్ దిస్ ప్రాజెక్ట్. ఈ కోర్ కమిటీస్ యొక్క అడ్వైజర్స్ ప్రకారంగా మేము వేరియస్ యాక్టివిటీస్ను చేస్తూ ఉంటాం. దీనికి విజ్ఞాన్ ప్రసార్ నుండి కూడా కొన్ని ఎప్పటికప్పుడు కొన్ని సలహాలు సూచనలు వస్తుంటాయి. ఫండింగ్ అంతా వారే ఇస్తారు. దీంట్లో ప్రధానంగా జరిగే యాక్టివిటీస్ ఏంటంటే 2 తెలుగు రాష్ట్రాల్లో కూడా శాస్త్ర ప్రచారాన్ని తెలుగులో చేయడం అనేది ఒక మెయిన్ ఆబ్జెక్టివ్ ఆఫ్ దిస్ ప్రాజెక్ట్. అందులో భాగంగా ఆంధ్రప్రదేశ్ అండ్ తెలంగాణ రాష్ట్రాల్లో కూడా ఈ యొక్క ప్రాజెక్టును 2021 ఆగస్టు నుండి నిర్వహిస్తున్నాం. ప్రతి నెల కూడా విజ్ఞానం అని ఒక సైన్స్ మ్యాగజైన్ తెలుగులో వస్తుంది. ఇప్పుడు ఆగస్టు 2021 నుండి ఈ నవంబరు 2020 వరకు అన్ని ఇష్యూస్ కూడా ఆల్రెడీ వచ్చి ఉన్నాయి ఆన్లైన్లో. ఇవి ఎన్ఐటి వరంగల్ వెబ్సైట్లో ఉంటాయి, ఆల్ బ్యాక్ వాల్యూమ్స్. తర్వాత విజ్ఞాన ప్రసార్ వెబ్సైట్లో కూడా ఉంటాయి. దాదాపుగా ఈ మ్యాగజైన్ను అన్ని గ్రూపులలో కూడా షేర్ చేస్తున్నాం. ముఖ్యంగా విద్యార్థులకు విజ్ఞప్తి ఏంటంటే ఈ మ్యాగజైన్ తప్పనిసరిగా మీరు చదవాలి. ఇందులో చాలా గొప్ప గొప్ప శాస్త్రవేత్తలు సైన్స్ అండ్ టెక్నాలజీ ఆర్టికల్స్ రాస్తున్నారు. కాబట్టి దయచేసి ఈ మ్యాగజైన్ను ఉపయోగించుకోవాల్సిందిగా కోరుతున్నాను. ఇందులో ఈ మ్యాగజైన్లో రాయడానికి మీకు కూడా అవకాశం ఉంటుంది. కాకపోతే సైన్స్ అండ్ టెక్నాలజీకి సంబంధించిన అంశాలను మీరు తెలుగులో రాసి ఇవ్వాల్సి ఉంటుంది. దాన్ని మేము డిటిపి చేసి ఈ మ్యాగజైన్లో ప్రచురిస్తాం ప్రతి నెల. దట్ ఈజ్ వన్ యాక్టివిటీ. రెండవ యాక్టివిటీగా వెబినార్స్, ఆన్లైన్ వెబినార్స్ను కండక్ట్ చేస్తున్నాం. ఇది 60వ వెబినారు. స్కూల్స్ లెవెల్ నుండి యూనివర్సిటీ లెవెల్ వరకు రకరకాల కాలేజెస్కు ఈ వెబినార్ లెక్చర్స్ను సైన్స్ అండ్ టెక్నాలజీ టాపిక్స్ మీద నిర్వహిస్తున్నాం. ఆంధ్రప్రదేశ్లో కూడా దాదాపు 15 వెబినార్స్ను కండక్ట్ చేసి ఉన్నాము. ఈరోజు డాక్టర్ బర్లా వెంకట్ గారి సహకారంతో వారి కాలేజీ విద్యార్థులకు ఈ యొక్క వెబినార్ను మేము కండక్ట్ చేస్తున్నాం. అంతేకాకుండా అనేక ముఖ్యమైన రోజులలో వర్క్షాప్స్ కూడా కండక్ట్ చేస్తున్నాం. ముఖ్యంగా నేషనల్ సైన్స్ డే సందర్భంగా ఫిబ్రవరిలో 7 రోజుల పాటు ఆజాదీ కా అమృత్ మహోత్సవ్ పేరుతో సైన్స్ సంబరాలను నిర్వహించడం జరిగింది. దేశమంతటా కూడా 75 ప్రాంతాలలో. మన తెలుగు రాష్ట్రాలకు 5 ప్లేసెస్లో ఈ యొక్క యాక్టివిటీస్ నిర్వహించడానికి అవకాశం ఇచ్చారు. హైదరాబాద్లో ఎన్ఐఎన్లోను, తర్వాత ఎన్ఐటి వరంగల్లో, తర్వాత విజయవాడలో స్కూల్ ఆఫ్ ఆర్కిటెక్చర్లో, విశాఖపట్నంలో ఆంధ్ర యూనివర్సిటీలో, తిరుపతిలో డిస్ట్రిక్ట్ సైన్స్ సెంటర్లో ఈ వారం రోజుల పాటు సైన్స్ సంబరాలను జరుపుకున్నాం. అది ఒక పెద్ద లెవెల్లో జరిగిన విజ్ఞాన తంతు. అది భారతదేశంలో గతంలో ఆ లెవెల్లో జరిగిందని నేను అనుకోవడం లేదు. ముఖ్యంగా విద్యార్థులు ప్రతి సెంటర్లో ఒక దాదాపు 20,000 నుంచి 50,000 వరకు విద్యార్థులు వచ్చి ఆ యొక్క అక్కడ ప్రదర్శించిన ఎగ్జిబిషన్స్ను డిఆర్డిఓ, ఇస్రో అండ్ డిస్ట్రిక్ట్ ఫారెస్ట్, మెడికల్ కాలేజెస్, ఇంజనీరింగ్ కాలేజెస్, అక్కడ లోకల్ ఇన్స్టిట్యూషన్స్ అందరూ కూడా వారి యొక్క అచీవ్మెంట్స్ను అక్కడ ప్రదర్శనలో పెట్టారు. అది విద్యార్థులకు చాలా ఉపయోగకరంగా ఉండింది. అలాగే 75 సంవత్సరాల సందర్భంగా 75 బీచ్లను కూడా క్లీన్ చేయాలని ఒక యాక్టివిటీ స్వచ్ఛ సాగర్ సురక్షిత సాగర్ అని ప్రైమ్ మినిస్టర్ మోడీ గారు తీసుకున్నారు. అది మనకు జూన్ నుండి సెప్టెంబర్ 17 వరకు దాదాపు 75 డేస్ ఆ బీచ్ క్లీనింగ్ యాక్టివిటీ జరిగింది. అందులో భాగంగా మనకు 3 ప్రాంతాలలో 9 బీచ్లు ఇచ్చారు. కాకినాడ, విశాఖపట్నం, శ్రీకాకుళం. కాకినాడలో సెప్టెంబర్ 1, విశాఖపట్నం సెప్టెంబర్ 2 అండ్ శ్రీకాకుళంలో సెప్టెంబర్ 3 రోజు మేము వర్క్షాప్స్ నిర్వహించాం. మా డైరెక్టర్ గారు కూడా కాకినాడ జేఎన్టీయూలో జరిగిన కార్యక్రమంలో పాల్గొని ఆ బీచింగ్ క్లీనింగ్ యాక్టివిటీలో కూడా వారు ఆ రోజంతా మాతో ఉన్నారు. విశాఖపట్నం, శ్రీకాకుళంలో కూడా అలాగే జరిగింది. హాఫ్ డే వర్క్షాప్, హాఫ్ డే బీచ్ క్లీనింగ్ యాక్టివిటీ. అక్కడ ఎన్ఎస్ఎస్ విద్యార్థులు, తర్వాత ఎన్సిసి విద్యార్థులు, తర్వాత ఉత్సాహవంతమైన విద్యార్థులు, ముఖ్యంగా ప్రెస్ విలేకరులను అందరినీ తీసుకెళ్లి బీచ్ క్లీనింగ్ యాక్టివిటీ చేసి బీచ్లను ఎందుకు క్లీన్గా ఉంచుకోవాల్సిన అవసరాన్ని తెలియచేయడం జరిగింది. తర్వాత మనం వర్కింగ్ జర్నలిస్టులకు కూడా శాస్త్ర ప్రచారాన్ని ఎలా తీసుకెళ్లాలి, ప్రింట్ అండ్ ఎలక్ట్రానిక్ మీడియా అనే దాని మీద గవర్నమెంట్ ఆఫ్ ఇండియా వర్కింగ్ జర్నలిస్టులకు వర్క్షాప్ పెట్టమన్నారు. 3 వర్క్షాప్స్ను కూడా హైదరాబాద్, విజయవాడ, విశాఖపట్నంలో పెట్టాం. అలాగే వర్కింగ్ జర్నలిజం విద్యార్థులకు కూడా, ఇది చదువుతున్న విద్యార్థులకు కూడా, జర్నలిజం స్టూడెంట్స్కు మళ్ళీ 2 డే వర్క్షాప్స్ను కూడా 3 వర్క్షాప్స్ పెట్టాలి ఉంది. అందులో హైదరాబాద్లో ఒక వర్క్షాప్ ఆల్రెడీ జరిగింది. తర్వాత విజయవాడలో కూడా నాగార్జున యూనివర్సిటీలో జరిగింది. ఇంకొక వర్క్షాప్ త్వరలో జరగబోతుంది. అట్లాగే ఆస్ట్రానమీ మీద ముఖ్యంగా సైన్స్ టీచర్స్కు ఆస్ట్రానమీ మీద అవగాహన కల్పించడానికి 3 వర్క్షాప్స్ పెట్టాల్సి ఉంది. అది కూడా ఆంధ్ర ప్రాంతంలో ఒక వర్క్షాపు, వరంగల్లో ఒకటి, హైదరాబాద్లో ఒకటి వర్క్షాప్స్ త్వరలో పెట్టబోతున్నాం. అట్లాగే రాబోయే రోజులలో నేషనల్ మ్యాథమెటిక్స్ డే డిసెంబర్ 22 రోజు, తర్వాత మళ్ళీ 23 వచ్చే నేషనల్ సైన్స్ డే ఉత్సవాలను కూడా భారీ లెవెల్లో జరగడానికి ఈ స్కోప్ ప్రాజెక్ట్ ద్వారా చాలా అవకాశం ఉంది. దాని యొక్క ప్లానింగ్ చేస్తున్నాం. దయచేసి ఏ ఇన్స్టిట్యూట్ అయినా ముందుకు వచ్చినట్లయితే వాళ్ళతో కొలాబరేషన్ చేసుకొని ఇలా వర్క్షాప్స్ పెట్టడం, తర్వాత లెక్చర్స్ను అరేంజ్ చేసుకోవడం ఇందులో అవకాశం ఉంది. కాబట్టి ఇందులో పాల్గొంటున్న శ్రోతలు కూడా దీన్ని తెలుసుకొని ఈ స్కోప్ ప్రాజెక్టును ఉపయోగించుకోవాల్సిందిగా కోరుకుంటున్నాను. సో ఐఎమ్ వెరీ థ్యాంక్ఫుల్ టు టుడే స్పీకర్ డాక్టర్ మార్తాయన్ రెడ్డి గారు. ఈరోజు ఖచ్చితంగా ఈ వెబినారు జరపాలని నిర్ణయించిన తర్వాత మాకు ఒక ఫస్ట్ ప్రొఫెసర్ రామచంద్రయ్య గారు అనుకున్నాము, వారికి ఈ వేరే బిజీగా ఉండడం వల్ల దెన్ వీ హావ్ రిక్వెస్టెడ్ మార్తాయన్ రెడ్డి గారు. వారు వెంటనే ఈ ఇంపార్టెంట్ టాపిక్ ఏదో ఒప్పుకున్నారు. థ్యాంక్ యూ వెరీ మచ్ సార్. ఈరోజు నేషనల్ ఎడ్యుకేషన్ డే కూడా, ఆ సందర్భంగా మీ అందరికీ శుభాకాంక్షలు తెలియజేస్తూ, ఎవ్రీ ఇండివిజువల్ హ్యాస్ ఎ రైట్ టు అన్ ఎడ్యుకేషన్ దట్ విల్ ఎనేబుల్ హిమ్ టు డెవలప్ హిస్ ఫ్యాకల్టీస్ అండ్ లివ్ ఎ ఫుల్ హ్యూమన్ లైఫ్. అంటే ప్రతి ఒక్కరికి విద్య చాలా అవసరం, కంఫర్టబుల్ జీవితాన్ని గడపడానికి. ఈరోజు నేషనల్ ఎడ్యుకేషన్ డే ఎందుకు జరుపుకుంటున్నామంటే, సో ఇది ఈరోజు బర్త్ యానివర్సరీ డే డాక్టర్ అబ్దుల్ కలాం ఆజాద్ గారి యొక్క బర్త్డే. వారు మనకు ఫస్ట్ ఎడ్యుకేషన్ మినిస్టర్ కూడా, మన స్వతంత్ర భారతంలో ఫస్ట్ ఎడ్యుకేషన్ మినిస్టర్గా వారు ఉన్నారు. వారి యొక్క బర్త్ యానివర్సరీ డే సందర్భంగానే భారత ప్రభుత్వం నేషనల్ ఎడ్యుకేషన్ డేను ప్రతి నవంబర్ 11న జరుపుకుంటున్నాం. ఆ సందర్భంగా మీ అందరికీ శుభాకాంక్షలు తెలియజేస్తూ, నౌ ఐ రిక్వెస్ట్ అవర్ బిలవ్డ్ డైరెక్టర్ ప్రొఫెసర్ ఎన్వి రమణ్ రావు గారు టు సే ఫ్యూ వర్డ్స్ ఆన్ దిస్ ఇంపార్టెంట్ అకేషన్. థ్యాంక్ యూ సార్.
Thank you very much. A very good morning to all the distinguished guests. Shri Martha Reddy Garu, Shri Dr. V. Barla, my former colleague Professor A. Ramchandraya, and present scope coordinator and chief Professor Lakshma Reddy, and my dear participants. At the outset, let me take this opportunity to congratulate the scope team for organizing the 60th webinar on a topic of great importance, emergence of light and photonics. In fact, you should excuse me for not speaking in Telugu. I don't know the translation of light and photonics in Telugu, but I hope the majority of the people can still understand. I'm just giving only introductory portion. It's very good that since the project has been sanctioned, as listed by Professor Lakshma Reddy, a lot of activities have been taken out. Not only that, we are coming out with a weekly magazine, monthly magazine, and I can tell with confidence that among all the centers sanctioned in the country, our center has been rated as the best by DST, because I am having regularly interaction with the DST secretary. In fact, Vigyan Prasar and DST are very happy with our work, especially in communication of science and popularization, and all the activities which Professor Lakshma Reddy mentioned have received overwhelming response from all sections. I myself traveled to Kakinada and I have seen the response, and such a great initiative taken by the government of India, especially in the regional language, the local language, because we know that if something is taught in the local language, something is communicated in the local languages, majority of the people can easily understand. So today, many of the problems are coming because majority of the people are not aware of the scientific basis, and they have many false beliefs. So if you can communicate in a language which is understandable to the rural people, to the common people, I think that is objective. And this program is being conducted during the period of Azadi Ka Amrit Mahotsav, which is again a great achievement for all of us to see the Honorable Prime Minister motivating us and driving all of us to do our best, especially with the National Education Policy 2020. And today is the National Education Day. And I think the National Education Policy also, apart from throwing light on multi-institute, multi-disciplinary, multilingual, is another key aspects of thing. And I think the scope today in India is being undertaken in different languages, and in Telugu for the both states of Andhra Pradesh and Telangana. NIT Warangal has been given the responsibility, and we are doing a wonderful job. I'm very happy with the coordinators. In fact, coming to the topic, emergence of light and photonics, I remember this topic in terms of when I was doing the recruitment. My experts in the physics said, sir, you have to recruit people from photonics because this is one area, and photonics today plays a very important role in driving innovation in increasing number of fields. Today it has got application across several sectors such as optical data communications, to imaging, to lighting and displays, to manufacturing sector also, to life sciences, healthcare, security and safety. In fact, today the photonics department at NIT Warangal is very strong, and we see by training, in fact, photonics is today shaping the Europe's digital future, and I strongly believe, that by training students, by doing capacity building in the area of photonics, there are several advantages like immunity from electromagnetic interference, freedom from electrical short circuits or ground loops, safety in combustible environments, security from monitoring, low-cost transmission, large bandwidth, and small size, lightweight, and very inexpensive. These are so many advantages that have come in these photonic integrated circuits. So I'm sure that this topic of emergence of light and photonics will go a long way in adding knowledge to the several participants who have joined today. So thank you very much, Professor, and thank you once again, the guest, Professor Martha Reddy and Dr. Barla, our distinguished alumni, for taking part in this important webinar. And once again, I take this opportunity to congratulate the organizers and wish you all good luck. Thank you very much.
Thank you very much, sir, for your wonderful words on this occasion. Now I invite Dr. Venkata Balla, so Academic Director, Rajaratna Kids Engineering College, Ramachandrapuram, to say a few words on this occasion. Over to.
Thank you, sir. Firstly, thank you very much, sir. Am I audible?
Yeah.
Professor Dr. Raman Rao, sir, Director, NIT Warangal, Professor Ramachandra Garu, Dr. Martha Reddy Garu, Professor K. Lakshman Reddy Garu, and other colleagues and friends. It's very exciting, first of all, to associate with the NIT Warangal, my own alma mater. And it was very exciting news when I met Professor K. Lakshman Reddy Garu at NIT Warangal recently. He explained to me the activities being done under the SCOPE project. And I instantly discussed that, sir, we should do something about for the rural students also. And we being located at Ramachandrapuram near Kakinada, and we have students below poverty line, almost 1,000 students join every year in different courses like nursing, we have pharmacy, we have pharmaceutical engineering, we have core engineering disciplines up to mining and agriculture besides traditional branches. And this is a group of institutions project and do this. Thank you very much, sir, for giving us this opportunity to associate with an internationally famous institution like NIT Warangal. And I was seeing recently the rankings of engineering colleges. So many international level institutions are below NIT Warangal. So many IITs are below NIT Warangal. And I feel quite proud such institution we are able to build, especially under the leadership of our director, Sri Raman Rao sir. We have really gone the institution building. Leadership of our Alapati Prasad Garu also. We have initiated so many activities, especially during kids who were about to die. We have saved them with the oxygen cylinders, with the beds and everything. So alumni are doing their might to strengthen our institution. And coming to today's topic, Maulana Abdul Kalam Azad sir's birthday today, and RIP sir, and you are listening from the heavens. Our greetings to you. And why we are celebrating this National Educational Day is because it is the birthday of a pioneer in modern education in India after independence. During the previous 200 years, Indian education system was destroyed under the British rule. And while the rest of the world was progressing, India was under slavery. The whole educational fabric of the India was destroyed. After that, after 1947, we started our educational journey again under the leadership of Professor Abdul Kalam Azad sir. He was a great educationist, and he was pioneer in not only the AICTE, which started in 1943 as a committee to study the educational system in India. Several reports were submitted by AICTE, which was recognized as a statutory body in 1987. Then the AICTE activities started. Before that, Azad sir was instrumental in starting UGC, University Grants Commission. He started, which heralded the development of modern educational system in India. And Azad sir was also instrumental in starting Jamia Millia University in Delhi. Delhi University itself was started by him with such an educational contribution. And we are celebrating this National Educational Day. And in our institution also, in our group institutions also, along with our parent organization, NIT Warangal, we are, and I'm proud to say that we have an MOU with the Alumni Association of NIT Warangal, global body. We have an MOU. We are conducting several activities, guest lectures, training programs, certificate courses. Every activity in the campus goes on in the name of the NITWA, NIT Warangal Alumni Association. So that way we are doing our Uduta Bhakti Antaru. Uduta Bhakti ante the squirrel which contributed to the building of the culvert started by Rama. Similarly, we ourselves are through NIT Warangal Alumni Association, we are strengthening the NIT family. Having said that, now coming to the today's topic, photonics was a very dear subject to me. When I was student in NIT Warangal, I used to read Resnick and Halliday, Volume 1 and Volume 2, very fondly. And all those memories are there. And photonics is making very high strides in the world today. Yesterday also, I had a seminar on photonics. We asked the students why the Earth, why the temperature goes down as you go towards the sun, and why it is hot in the Earth here. So these kind of seminars we've been having and spreading the science and technology in our own way. And we ourselves have given several projects to students. The most recent project I've given is the project of electricity transmission without cables for long distances. So this is the project our students are doing. This is allied to the photonics anyway. So, and of course, the solar energy, solar electricity come under the broad umbrella of the photonics alone. I think without photonics, we can't see human life on this earth anyway. So we are doing our might, and with these few words, I would not like to take, because I'd like to hear Professor Mahatma Reddy than speaking on this occasion. I thank you, Lakshman Reddy sir, once again for giving this opportunity. We look forward for many more opportunities in future. We have several groups here along with us, and we have a group of companies, group of institutions under our umbrella. Each campus would be happy to associate on several diversified topics. We have professors from NITs, IIT, IIMs, Anna University, Andhra University, Osmania University, NIT Warangal, We have professors working in our group of institutions. We'll be happy to strengthen your mission and participate widely on various programs that you are initiating. Thank you very much. Thank you all. Greetings to everybody.
So thank you very much, sir. We are also equally happy to associate with you, and let us hope that we will have some more programs in collaboration with you and with your own institutions and others. Thank you all your support. Now I invite Professor Ramachandra Garu to introduce the today's speaker, Dr. Martha and Reddy. Over to Professor Ramachandra Garu. Sir, unmute చేసుకోండి. ఇది వాయిస్ రావట్లే. రామచంద్ర గారు.
Now it's all right, sir. Speak on, Ramachandra, sir.
రామచంద్ర గారు, వాయిస్ రావట్లేదు సార్.
He's not looking at us. Oh, why he has, but it's not transferred to us.
సంధ్య,
సార్
సార్ చెప్పు, వాయిస్ రావట్లేదని
చెప్పాను సార్. చూస్తున్నారు, రావట్లేదు సార్.
సార్ మీరు సంధ్యా సిస్టమ్ దగ్గరకు వచ్చి మాట్లాడండి. సంధ్య, మరి సంధ్య సిస్టమ్ దగ్గర నుంచి కాండి. ఏమో అక్కడికి పోయి వెళ్ళా, అక్కడ బాగానే ఉంది. హలో సార్, రామచంద్ర గారు. సంధ్య
సార్ రీజాయిన్ అవుతున్నారు సార్.
ఎక్కడ? అక్కడనేనా?
ఇక్కడనే సార్. ఇక్కడనే సార్.
మీ దగ్గర?
సార్ ల్యాప్టాప్ లోనే మళ్ళీ రీజాయిన్ అవుతున్నారు.
మీ దగ్గర నుంచి కమ్మనండి, లేట్ అవుతుంది.
Sir, I think kindly start the lecture.
Doesn't matter. I myself introduced. Don't worry.
Okay.
Don't worry.
Otherwise, I will do it, sir. I too have your.
Okay, please.
Yeah.
It's not
Yeah,
very
audible,
important.
sir.
It's not very important.
Yeah. రామచంద్ర గారు.
Right now audible.
Okay. Professor N.V. Ramanarao garu, our beloved director, NIT Warangal, and also chairman the Scope Project Telugu. Professor Barla Venkat, our very proud alumnus, and also the director of academics at Rajaratna Kids Engineering College, Ramachandrapuram. ప్రొఫెసర్ లక్ష్మారెడ్డి గారు, ప్రిన్సిపల్ ఇన్వెస్టిగేటర్, స్కోప్ ప్రాజెక్ట్ తెలుగు అండ్ ప్రొఫెసర్ ఆఫ్ హెచ్ఏజీ ఎన్ఐటి వరంగల్ కెమిస్ట్రీ. డాక్టర్ మార్తా ఎన్ రెడ్డి గారు, మై బెస్ట్ ఫ్రెండ్ అట్ యూనివర్సిటీ ఆఫ్ హైదరాబాద్, అండ్ వీ వర్ contemporary for about nearly 3 years at University of Hyderabad, Gachibowli. That time there was very forest-like environment all around Gachibowli compound wall. It used to be only a yard, it used to be something like 50 rupees that time. Now it must be 50 lakhs or so. So ఇక్కడ ముందు పెద్దలు చెప్పారు, ఇప్పుడు తెలుగులో ఈ ప్రాజెక్ట్ నడుస్తుంది కాబట్టి ది ఇంపార్టెన్స్ ఆఫ్ కండక్టింగ్ సైన్స్ ప్రమోషన్ యాక్టివిటీస్ ఇన్ తెలుగు మదర్ టంగ్ అనేది మనకు బాగా అర్థమవుతుంది. మనకు నేషనల్ ఎడ్యుకేషన్ పాలసీలో కూడా మాతృభాషలో విద్యా బోధన ఏమైనా యూనివర్సిటీ స్థాయి వరకు కూడా చేయాలని చెప్పేసి చెప్పారు. ఇంతకుముందు పెద్దలు ప్రొఫెసర్ రమణరావు గారు, ప్రొఫెసర్ లక్ష్మారెడ్డి గారు చెప్పినట్టుగానే ఇప్పుడు ఆధునిక విజ్ఞానం బాగా ఉండాలంటే భారతదేశంలో మాతృభాషలో ఉండాలని ఈ మధ్య గవర్నమెంట్ ఆఫ్ ఇండియా ఆల్సో స్టార్టెడ్ ఆఫరింగ్ MBBS program in Hindi medium for the states. దాని దృష్టిలో ఉంచుకొని చాలా యాక్టివిటీస్ కొత్త చేస్తున్నాము. ఈ 60వ వెబినార్ కు ఆతిథ్యం ఇవ్వడమే కాకుండా ఇందులో భాగస్వాములైనటువంటి రాజరత్న కిడ్స్ ఇంజనీరింగ్ కాలేజీ వారికి కూడా ప్రత్యేకమైనటువంటి ధన్యవాదాలు తెలియజేస్తూ, మా మిత్రుడు అలాగే సైన్స్ పాపులేషన్ లో తన వంతు కర్తవ్యాన్ని చేస్తున్నటువంటి డాక్టర్ మార్తా ఎన్ రెడ్డి గారిని గురించి పరిచయం కోసంగా నేను చాలా సంతోషిస్తున్నాను. వర్క్ టుగెదర్ యాక్చువల్లీ ది సేమ్ హాస్టల్ అండ్ ది సేమ్ బ్లాక్ ఫర్ నియర్లీ 3 years as I told in the beginning itself. డాక్టర్ మార్తా ఎన్ రెడ్డి గారు బిఎస్సిని ఉస్మాన్ యూనివర్సిటీ హైదరాబాద్ లో కంప్లీట్ చేశారు. తర్వాత ఎంఎస్సి, తర్వాత ఎంఫిల్ హైదరాబాద్ సెంట్రల్ యూనివర్సిటీ చేశారు, స్కూల్ ఆఫ్ ఫిజిక్స్ లో. ఆ తర్వాత వారు ఐఐటి కాన్పూర్ లో పిహెచ్డి చేసిన తర్వాత 1989 లో వారు లేజర్ సైన్స్ అండ్ టెక్నాలజీ సెంటర్ అయినటువంటి దీంట్లో మన డిఆర్డిఓలో జాయిన్ అయ్యారు. ఆఫ్ కోర్స్ యు నో ది ఇంపార్టెన్స్ ఆఫ్ డిఆర్డిఓ దిస్ డేస్. ఇప్పుడు మారుతున్నటువంటి అంతర్జాతీయ పరిస్థితుల్లో డిఆర్డిఓ యొక్క హెల్ప్ చాలా అనన్యమైనటువంటిది అన్నట్టు. దాంట్లో చాలా కీలకమైనటువంటి చాలా కాన్ఫిడెన్షియల్ కీ ఆస్పెక్ట్స్ లో వారు పనిచేశారు. వైస్ ప్రెసిడెంట్ గా, డిప్యూటీ డైరెక్టర్ గా వారు రిటైర్ అయ్యారు. తర్వాత ఆయన హయాంలోనే లాట్ ఆఫ్ కీ ఫెసిలిటీస్ అండ్ టెక్నాలజీస్ have been created in DRDO. He led research groups as project director and developed several niche technologies including high power fiber lasers and adaptive optics for directed energy weapon applications. He also developed Raman scattering based standoff explosives and IED detectors which have been manufactured in many numbers and delivered to different Indian security agencies. తర్వాత 2018 లో వారు పదవీ విరమణ చేసిన తర్వాత చాలా సంస్థలకి వారు సలహాదారులుగా ఉండడమే కాకుండా ఆయన సొంతంగా వ్యక్తిగత స్థాయిలో కూడా పాఠశాలకి విద్యాలయాలకు వెళ్ళి సైన్స్ యొక్క ఇంపార్టెన్స్, సైంటిఫిక్ టెంపర్ యొక్క రిలవెన్స్ చెప్పడమే కాకుండా చిన్న ప్రయోగాలు, చిన్న టాయ్స్, లో కాస్ట్ మెటీరియల్స్ కూడా తీసుకొని వాటి ప్రయోగాల ద్వారా పిల్లలకి చిన్నపాటి విద్యార్థులకు సైన్స్ బాగా అవగాహన అయ్యేలా వారు కృషి చేస్తున్నారు. సైంటిఫిక్ టెంపర్ ప్రమోషన్ అనేది ఆయనకున్నటువంటి ప్యాషన్. ఇప్పుడు మేము బహుశా మార్తా రెడ్డి గారిది ఇది 2వ వీడియో అనుకుంటున్నాం మా స్కోప్ సిరీస్ లో. తర్వాత ఇప్పుడు ఇంతమంది పెద్దలు చెప్తారు ఈ ఫోటానిక్స్ యొక్క ఇంపార్టెన్స్. పార్లమెంట్ గారు చెప్పారు, అలాగే మా ప్రొఫెసర్ రమణరావు గారు, మా డైరెక్టర్ గారు చెప్పారు. అలాగా వీఆర్ గోయింగ్ టు లిసన్ ఎ లాట్ ఫర్ ద అప్లికేషన్స్ ఆఫ్ ఫోటానిక్స్ అండ్ లేజర్స్. వాళ్ళు ఎక్కడ తీసుకున్నా కూడా మీరు ఇప్పుడు మన ఏవి తీసుకున్నా కూడా అవి లేజర్స్, ఫోటానిక్స్ యొక్క ట్రాన్స్డక్షన్స్ లేకుండా ఇప్పుడు ఏ యొక్క టెక్నాలజీ కూడా లేదు. ఆల్ సెన్సిటివ్ ఎక్విప్మెంట్, మీ సెల్ ఫోన్స్ వాడుకున్నా కూడా అవన్నీ మోస్ట్ ఆఫ్ ద థింగ్స్ ఆర్ గోయింగ్ టు బి డన్ ఓన్లీ బై లేజర్ ఫినిషింగ్. మీకు సర్క్యూట్ అంత తక్కువ స్థలంలోనే డిఫరెంట్ లైన్స్ టు బి సపరేటెడ్ ఫ్రమ్ వన్ అనదర్ అంటే క్రాస్ కాకుండా ఉండాలంటే లేజర్ లిథోగ్రఫీకి మాత్రమే అది ఎచ్చింగ్ వల్ల మాత్రం వీలవుతుంది. అలాగే 2022లో ఫిజిక్స్ నోబెల్ ప్రైజ్ కూడా క్వాంటమ్ ఎంటాంగిల్మెంట్ కి ఇచ్చారు. అందులో కూడా 2 ఫోటాన్స్ హౌ దే ఆర్ గోయింగ్ టు ఇంటరాక్ట్ విత్ ఈచ్ అదర్ అని చెప్పారు. అంటే జీరో రెస్ట్ మాస్ ఉన్నటువంటి ఫోటాన్స్ కూడా ఇవాళ చూడగలిగినటువంటి స్థాయి ఎందుకంటే ఇది ఫోటానిక్స్ యొక్క బహుశా మేబీ జెనిత్ ఆఫ్ ఫోటానిక్స్ ఇంజనీరింగ్ అనుకోవచ్చు. అటువంటి సబ్జెక్ట్ ను మనం వినడం కోసం ఆసక్తికరంగా ఎదురుస్తున్నాము. ఐ రిక్వెస్ట్ డాక్టర్ మార్తాండ్ రెడ్డి గారు టు గో హెడ్ విత్ హిస్ టాక్ as far as possible in Telugu. Now and then, of course, as far as the is concerned, of course, we can use
right. Thank you, Professor Ramchandra garu and respected Director NIT Warangal and Director Academics Dr. Barla of RR Kids and my friend and then coordinator of Scope Professor Lakshmana Reddy garu, Ramchandra garu, and moreover, I would like to thank this committee and all those people, particularly I suppose Dr. Barla, who has I think organized for their students, and I know that there are a lot of engineering graduates, engineering students, and I'm very, very happy to interact with them. It's not a lecture, but I would like to have a kind of interaction because I believe in transferring some skills and understanding the very, very basic but very profound insights of the science. Okay, so in this lecture, obviously I'm going to talk a little bit about science and its importance and how science is transferred into technology as well, besides the photonics. So we all know that we are living in a very advanced technological arena, and you are very lucky that you have so much of time. I'm addressing to students, and they have so much of time. They are the beginners of this advanced technology age, and I'm sure they are going to see many more advanced technologies. And I would like to say that the light and photonics, whether we believe or not, it is the technological revolution that we are living in this the present revolution is the technological revolution is the of photonics after digital electronics. So we would like to talk about the applications, how this has spread to all walks of life in all technologies, part of all the smart systems that we develop today and use them. So we call them, let's say, sometimes optoelectronics, electro-optics, then sometimes, all this together called photonics. And okay, I would like to first share the screen. Yeah, I should have done it. So as you see that photonics is the new innovation in the field of, let us say, electronics.
share అవుతున్నట్లేదు కదా మార్తా?
Optoelectronics. Pardon?
Screen share అవుతున్నట్లేదు?
Screen is not being shown?
Not visible.
Okay.
Full screen అనండి.
Yeah, host disabled to participate screen sharing. Why?
సంధ్య హోస్ట్ డిజేబుల్డ్ అని వస్తుంది కదా. యువర్ ఆల్సో హోస్ట్ నో, మీకు కో-హోస్ట్ ఇచ్చుంటారు.
So are you able to see now?
నాట్ ఈవెన్ నౌ.
Okay, what is the
కింద గ్రీన్ కలర్ లో ఉంటుంది కదా ఒకటి స్క్రీన్ షేర్ అని, షేర్ స్క్రీన్ ఉంటుంది. దీనిలో అప్ మార్క్ ఉంటుంది, అప్ యారో ఉంటుంది.
Yeah, screen share.
ఆ తర్వాత స్క్రీన్ వస్తుంది, స్క్రీన్ లో మీ యొక్క పిపిటి క్లిక్ చేయండి. Now it's coming, I think.
Oh, now it's coming.
Yeah, of course. Now we can show for reading. Slide show వెళ్ళండి.
Yeah.
ఆ పక్కన మూడోది కింద బటన్ రైట్ సైడ్. Yeah, right.
Yeah. Yeah.
Yeah, now it's good.
Now it's good. So inextricably we are living in the age of photonics. As I was telling, you know, we have gone through several scientific revolutions, as you know, from first three industrial revolutions, and then we are right now living in the fourth industrial revolution that is brought by obviously information technology. And we know that photonics is very much behind information technology, and we are also going to see many other advanced technology, including AI and deep learning and so many other technologies. Of course, these are all enabled by electronics. So we would like to discuss certain phenomena. To start with some fundamentals, my idea is to first we should have clear understanding of some of the basics in any course, any subject. So I'm a part of the physics, so I know that how important it is to understand various basic fundamentals in physics, so that we can understand several engineering tools also. So for example, we know that the rainbow is caused by light, and everyone knows that rainbow is formed due to the hanging raindrops in the far side in front of you. And but when we ask people, even many of the even lecturers and teachers, particularly teachers, let's talk. Everyone knows a little bit, but they will not be able to tell exactly what are the effects, what are the formulae, what are the laws involved in that. So we must learn whatever we see, and we must understand whatever we see and observe around us. That's what the science is. We'll just talk. And so just to define the photonics, see, photonics is the science and technology of generating, controlling, detecting photons. Photons are definitely a particle, quanta of light. The stream of quanta will generate light beam. So photonic underpins technology of daily life, as I was telling, right from smartphones to laptops, internet, now medicine, and many in defense, many gadgets and systems. For example, entire telecommunication is supported by the back end of telecommunication, supported by photonics as well. You know that fiber optic communication, and then all the networks, as I was showing here, is all supported, rather driven by the photonics. The transmission, basically transmitting the light from one end to other end and detecting it, and then the extracting the information. It's all done, all kind of under day by day, how much data rates are increasing. This is all because of light is one of the main reasons, photonics. So whether you call it silicon photonics, see, instead of the computer electronics, and if you go for silicon photonics, obviously the data rates would be very high, maybe several terabits, that kind of data rates. Then biophotonics, these days so much of research. In fact, most of the research in let us say in all subjects, is done is on biophotonics, biology, or we call even entire chemistry people, life sciences people, all engineering people, they work on biology. Let's say brain research, neural networks. These are so entire imaging and extracting the information. So everything is being done using photonics. That is why we are we can say without any doubt that we are living in the age of photonics. And 3D nano photonics, microwave photonics. We all even microwave also we can call photonics. Yeah, the first and foremost, we know that the essential application or the necessity of light is for the photosynthesis. Without that, there's no light. So we can say that light as well as fire are central for the human civilization. Also, many civilizations and many technological or revolutions have taken place. And then, as I said, we are right now living in the fourth industrial revolution, and photonics is a part of it. So, here we can see, scientific analysis and insights often need to explain the phenomena, whatever we see. For example, how the photosynthesis, what is behind, what are the chemical reactions, how this light energy is transformed into chemical energy, how the plants and other microorganisms which live upon through photosynthesis, they extract this energy. So we should know a little bit about. If a layman asks, we should be able to tell them. Likewise, I have written here how sun is emitting this light and what kind of spectrum it is. And of course, I'm not going to talk about in detail how sun is emitting light, but definitely it's very, very interesting physics. Just now, the Professor Lakshma Reddy said cosmology. Astronomy or cosmology is very interesting phenomenon. I think most of the new generation or even the old timers are interested in knowing what's happening in this space. Particularly in the US, if you see, the common man is more knowledgeable compared to the common man elsewhere about the cosmology, what is happening. And for example, recently Webb what is that? The telescope has been sent to space, and it is giving so high resolution pictures. Now we know that Neptune has got, for example, rings. Before that, we didn't know. So the James Webb telescope, infrared telescope, is the one which is giving. In fact, we are going to expect a lot many revelations in science is through this telescope. Earlier we had, of course, Hubble telescope. You all know that. So what I'm telling students that whatever we see, whatever we observe, whatever we experience, we must know a little bit in detail. Just reading would not be sufficient. Understanding is important. Okay, how light is produced? Sometimes I go to different schools. I ask them how light is produced. It is very difficult for even teachers. Sometimes they start Googling it. But one of the prominent emitters light is, as I have written down here, electroluminescence. That means that you need some material to get light emitted, isn't it? Whether it is chemiluminescence, bioluminescence, crystalloluminescence, electroluminescence, photoluminescence, and radioluminescence, sonoluminescence, even sound can emit light. How sound energy is transferred to light energy, and thermoluminescence, even heat. And the main thing is that you need materials. What materials? Any material, but they should have certain properties. Depending on those properties, it will emit the light in that spectrum, in that wavelength range. So, for example, atoms, basic atoms, definitely when you excite them with some, let's say, current passing through them, or you excite with the other light, so the atoms, from the ground state, they excited to the excited states, and then when they decay back to the ground states, they will emit photons of that energy difference between the excited state and the ground state. Delta is equal to h nu. Nu is equal to c by lambda. So the main thing is atoms or molecules are responsible for this. Of course, there can be ions and other things in a bioluminescence, and but atoms and molecules are definitely are the reason when we excite them, and the electrons from their ground state to different excited states, and then when they decay back. So laser is also one of them. We all know that everyone knows the light only as a illumination. We have wonderful light illuminations, some by nature, as you see the lightening, how charged, differently charged, within a same cloud when they meet, and these arcs takes place in the open. Flashes of lightning, and then of course, just now I said how the rainbows are formed, and later on we can discuss how various laws of physics or optics is involved within that formation, whether it is refraction, reflection, dispersion. All three things are involved in rainbow forming. So what I want to say is that rainbow is a good example. Everyone knows that rainbow is formed at the time of rain, just before the rain or just after the rain, at a 100 distance. So how it is done, we should know. Yeah? So of course I should. And the other one is you see the northern flashes of light, how in Canada and in the North Pole or other South Pole, how these very colorful, beautiful light are emitted in the atmosphere because of the charged particles when they fly from the solar flares.
డాక్టర్ సౌండ్ రావట్లేదు. హలో,
ఇది రావట్లేదు వాయిస్. మార్తాయన్ రెడ్డి గారు, సార్ ఇది డిస్కనెక్ట్ అయ్యాడు ఉన్నట్టున్నాడు.
Kindly call him on phone, sir.
Yeah.
Kindly make a call to him.
కరెక్ట్ గా లేదు. No, it's not audible.
Is my screen shown?
No.
Oh. just a minute.
Sir.
ఇంటర్నెట్ వచ్చింది కదా, ఇంటర్నెట్ వచ్చిందా? వైఫై వచ్చిందా?
అక్కడ పవర్ ఫెయిల్యూర్ ఉంది సార్, ఈజ్ రీకనెక్టింగ్ అవుతున్నారు. జస్ట్ 1 minute.
Yeah. Sorry.
Yeah, it's coming, sir. It's coming now.
There is a failure of electricity and thereby the.
Yeah. ఇప్పుడు అన్మ్యూట్ చేసుకోండి.
Yeah.
Yeah.
That's right. Okay. Sharing. Oh, is it seen? Is it there?
Yeah. Now you proceed.
Yeah, please
Yeah.
go ahead.
మోడ్లో పెట్టుకోండి.
Yeah.
Go for, yeah, fine.
Okay. Yeah. Faster. That is now. What is this light? We all know that light is an electromagnetic wave, right? So we know the electromagnetic spectra. I think every student has to know about this. Definitely, whether they are from electronics communications or from any core area. This is very much required because the entire gamut of communications and other sensing, all this done in these various electromagnetic spectra. As you see, this is a packet of photon is a packet of energy, and it is represented by electromagnetic wave, as I mentioned over here. So it has definitely a wavelength and a phase, and as you see here, the properties of light, various properties of light are manipulated in photonics to get our things done, to develop technologies for end use. So reflection, refraction, diffraction, interference, and then scattering, polarization. I added some of them: absorption, transmission, wavelength, energy, momentum. Obviously, a wave will have wavelength and energy, obviously, when it has got energy and momentum. Though the photon doesn't have the rest mass, it can still have momentum. In fact, the photons can knock you down, not as of our the weight, but definitely a nanoparticle. So that is how the Bose-Einstein condensation is being experimented or demonstrated. And these days, nanotechnology, we are all manipulating the motion of the nanoparticles using light, because they have it has momentum. I think we'll discuss that. So in this entire electromagnetic spectrum, visible range is very small, maybe 400 to 780. The rest we cannot see. But in photonics, these days everyone uses different bands, even though microwave, so microwave photonics we'll call it. But otherwise, mostly to visible and infrared, and sometimes even the ultraviolet is used very efficiently. So as you see, the basic property of light is scattering. and one of them is Rayleigh scattering. We all know that why the atmosphere or the sky and the water. So will not go more into details how, but a light beam or a photon, when it is passing through the atmosphere, it will scatter when it encounters certain atoms, molecules, and other little particulate matter of submicrons, microns. And scattering is more when the particle size is more. But with molecules, it will provide you the Rayleigh scattering at the same frequency. And Raman scattering, you say that it is also because of these molecules which emit at a different frequencies, not only at that frequency, but at a different frequency. So just wanted to show these pioneers of photonics. Many of you might be recognizing them, and these are some of the prominent people, though there are many of them. So I would like to urge students, to little bit know about each and their contribution, so that they can get a good idea, or they can get required inspiration from them, how they struggled to invent things and then innovate things. As you see, Max Planck, Newton, Einstein, Max Planck, Galileo, Niels Bohr, and then Maxwell, and Robert, and then he's forgetting. But there is one guy, you see down below, one Sardarji is there, one sick person. He would have been what people claim he would have been, got or identified and got a Nobel Prize for the fiber optics. In fact, he did quite good pioneering work. He was at IIT Delhi, but this guy from Japan got the, and you know how much important is that today, the fiber optics communication. As I said, the back end of the internet is the fiber optics communication. And so we must develop some curiosity to read about the biographies of great scientists, just to understand how they were thinking, how they struggled, and in their own words, how they have published the first articles and how they have been transformed later on. Okay. These are all Indian guys. Many of them you might recognize them, but definitely we must read about their biographies. And Homi Bhabha, all Jagdish, so many people, Ramanuja. So I'll not go to that. Last one is Vandal Kalam. Yes, as I told, we exploit the photonics people exploit the various bands of as I told, it is visible region and infrared region. And most of you people must be knowing these days the small region which was omitted earlier between infrared and the microwave. So that is called terahertz. So that is being exploited for various applications. One of them is for the detection of contraband, these explosives and then drugs. It is very good to know because this is low frequency radiation which can interact with those molecules, water-like molecules, and give the spectra, identifiable spectra. So as you see here, different region electromagnetic. So gamma ray, X-rays, of course, we know how they are used. Visible rays, infrared, we call short wave, mid wave, and long wave. So all thermal imaging. So these days in the night, in defense, we got to see the enemy's aircraft, fighter aircraft coming from, let's say, towards us. Even when it is, let's say 200 kilometers, we must recognize them. But then these days, even night, these infrared cameras are used. They can recognize, not only detect, but recognize and identify up to 40 kilometers very easily. And beyond the hundreds of kilometers, definitely they will see as a point. So this itself is a big area for research, and also a big area for the defense people, how thermal imagers are used for fighting in the nights. See, the spectrum of solar radiation in the outside atmosphere, black body radiation, and how solar radiation at the sea, various molecules are observed. I have a spectrometer and of course computer I could have shown, but I haven't prepared now. But when I visit friends directly, I show them how these peaks, absorption, radiation coming from sun, on the way it will encounter these molecules which are present in the atmosphere, and they are observed. That particular spectrum, that particular wavelengths are observed by these molecules. So they are the fingerprints of them. For example, oxygen at 759 nanometers, it has got a very good absorption. So it is very easy. Within 2 minutes we can find out, and also we can find out ozone at any level we want to monitor. So pollution monitoring, or some in a chemical warfare, when it takes place, enemy sprays chemical warfare, we can find out. So we call them ceilometers. Those days we used to call them lidars or lidars. So these days, okay, just a few transparencies on science. We know how important it is to pursue science. You're all pursuing science and technology. Engineering is an offshoot of definitely advanced branch of science, and we know science of today is the science of technology of tomorrow. So we should have some good understanding what is science, what is technology, what is system. So that itself will take 1 hour to talk about, but definitely you need science, understanding of science and scientific theories and laws to develop various technologies using engineering tools, right? And then these technologies are used for developing systems or gadgets. So that means that it is very important to understand science. For example, you are seeing here on the top, we can sense, in biology or in the biosamples, how various diseases or cells with affected cell with diseases, and many innovations. The microscopy, how these days is able to show us the atoms. A few years back it was not possible. Now we can see almost virtually the arrangement of atoms in some of the materials using very high resolution electron microscopes, and you can penetrate through, we call Doppler, what do you call the regime? We cannot diffraction limited. We can go beyond diffraction limited, and so one scientific invention can change the world forever. It is very true, and we have gone through several scientific innovations. Many of them. The invention of a transistor, how it changed entire in the world and our lives, computers are offshoot of that, and everything. And right now, the digital revolution, and then photonics, everything came from the invention of transistor, and obviously computer has got so many transistors or MOSFETs these days, and how wafers are created and chips are created, and robots, and the AI and augmented reality, all those stuff. So they're all offshoot of that. In science, when we want to learn these three things, I always what is it, how is it, and why is it? These three questions should be posed by us. So that means we should be curious enough to pose these questions. That if you are not curious, we will not be asking these questions. We will be simply listening whatever teacher or then we write examinations, and of course, whatever we read and remember, memorize, and then we write examinations, pass, and leave the subject. But we should remember that science is always, and scientific temper is always required to know what is around you, and then what is the technology. Tomorrow, students do not know what area of research or the technology they want to work with, and so they must have this kind of curiosity, and have the capacity to ask, what is it, how is it working, and why is it? So just to say that what is science, of course, the best definition I give is the science is nothing but common sense at its best, that is rigidly accurate in observation and merciless to the fallacy of logic. Merciless to the fallacy of logic. That means it has to be logical. It has to be built on rationality and reasoning. So someone said, none other than Edwin Hubble, who has given us the tremendous insight that the universe is expanding. Hubble telescope and Edwin Hubble, he said, equipped with his 5 senses, we have 5 senses, man explores the universe around him and calls the adventure as science. Such a beautiful definition. So that whatever senses, we have 5 senses, feel, touch, taste, vision, all these ones. So every time they will be in operating mode. So whenever we are watching TV, we are seeing the images and their emotions, everything. So from each thing we can find out what is happening. So that means that we should cultivate this kind of scientific temper to understand the world and understand everything, even management, how this whole world is working. If you are going for the management, also you need to know all these techniques and tools. Okay, and of course how science is required, why science is required, everyone knows. So, these days, those who are using smart phones, they all know they can't be free from it even for 10 minutes. So how important is that? And smartphone consists of many technologies. Okay. So what I wanted to mention, curiosity is the spark behind every discovery and innovation. So how to build, how to inculcate that kind of curiosity is the responsibility of a teacher. And see, even Albert Einstein said, I have no special talent. I'm only passionately curious. So we must be very curious. The degree of curiosity determines what you will become. This is what I would like to say. And, if you want to be a scientist, you must have the ultimate curiosity, but you want to become a good professional, definitely you need a lot amount of curiosity. And we must develop that right from the beginning. So, scientific temper. These days, I talk a little bit about the scientific temper. So it refers to an attitude of logical and rational thinking. And scientific method includes observation, inquiry, questioning, physical reality, testing, hypothesizing, analyzing, and communicating. Okay, the science is built, first, just by watching it or through our five senses, we want to find out. We become curious, and then we'll become inquisitive. Then what happens? Then we start asking the spirit of inquiry. Inquisitive, the spirit of inquiry is the main thing. Then we try to hypothesize. You want to find out what is, how the entire gamut of science and the laws of nature or physics is done is by hypothesizing. Afterwards, they conduct experiments, and depending on the results, they interpret them. If it is tallying with the formulas or the equations they generate, then it will become theory. Otherwise, they got to revise their hypothesis. So we must be logical, we must be skeptical, how, why, what. So as I said, spirit of inquiry is very important. So as I said, these are the stages: ask question, do background research, conduct a hypothesis. So these days we call modeling. So you want to simulate. First we got to construct a model. So it is, in a way, it is constructing a hypothesis. And we simulate these days, but here we test by experimentation, and then analyze the data and report the result, whether it is matching. Then it will become theory. And that theory is required to make use by the engineers to develop technologies. And the technologies are used to develop systems, gadgets. Okay. So I just listed them. First, what you should have curiosity, that should then that will turn out to be good knowledge. And then if you extract some inspiration by listening or by visiting or by interacting people, the inspiration will give you motivation, and motivation will be converted, obviously, a passion and an obsession. Because even though you are working very hard, if you have a passion, you don't feel tiresome. Then obviously you will develop skills and development. And when you add creativity to that, you will be inventing or innovating. And that is what required for developing system analysis and engineering. What is required and what system to be built. You should have all these qualities, all these dispositions. And then you will design, develop, test, evaluate, and then it goes to the user trial, QC, QT, quality, compliance, and then product, and then we do this. So these are the steps one should go through to develop something successfully and then market it. So this all. So if you don't have, we randomly do it, then we do not know where we go. So I said, if you don't know where you are going, any road will take you there. So this is a little blind research, blind way of doing things. So which we cannot afford to do this. These days, everything has to be planned. So doing more things is not a substitute for doing right things. It's very important in the management. We can be working right from the morning to evening, but without any positive result. So we must have this kind of. I have written sometimes this. When do you call a nation progressed? We should have educated, skilled, and empowered citizens. and we should have technologies and convert those technologies into systems for developing consumer products, infrastructure, services, consumption and exports. Other thing is self-reliance in defense technology, because we spend quite a bit of our budgets for defense systems, for buying systems. So half of our economy is spent for it. So if you are self-reliant, self-sufficient to begin, so DRD is one of the agencies, of course, ISRO and many other. So it has got a number of laboratories. Maybe we have 52 laboratories in the country. In fact, one should talk about, I would request our coordinator to, engage some person, or I can also speak all about what is the DRDO, what are the systems it is developing it, and how important. If we want to, let's say, import one Rafale aircraft, how much? 23,000 crores we are spending, you see. So that means half of our budget goes into that. So economic growth should be high. The ultimately what is reflected is quality of life of citizen should be good, if you say that the nation is. Okay, coming back to photonics. You see science through imaging or observation and characterization. These are the two, well-known familiar instruments. You see, one side is the microscope, another side is the telescope. The telescope sees everything, very big structures, mainly through sky, and then it gave a tremendous amount of information, insight about the cosmos. How, the stars and galaxies, and these days black holes, people say, and then the planets are formed, and how the universe is expanding in an accelerated mode. What are the reasons? So a lot of information it gave. So optical imaging and spectroscopy, it can also do spectroscopy. See, one of the main branches of photonics is spectroscopy, definitely. Those days we used to call optics, and there is a small difference between optics and the photonics. One is classical, another is the advanced optics. So it will give us a tremendous amount of information, explore and unravel the mysteries of micro and nano structures of the matter. And this fellow, the microscope, as I said, so much information definitely about all microsystem and the biological system, perhaps, chromosomes you can see these days, and then imaging, of course, a tremendous amount of advances have taken place in imaging, biotechnologies. So, our biophotonics, they say. So I mentioned these two instruments are very, very important. They gave us, and in fact, the entire quantum mechanics has been formed with the data which they have given us, particularly telescope. And you see how this is done, because the spectroscopy involves absorption of wavelengths, specific wavelengths by specific media, fluorescence, specific color of light will emit depending on the material, how their the atomic structure or the electronic structure is, scattering, reflection coefficient, change in polarization. These are the four main properties are utilized for detecting, characterizing all the material. Sometimes a change of polarization of light, when it passes through material, it changes. Then polarization spectroscopy, we can see so many these days 3D goggles when we are watching. Reflection changes, scattering, many type of scattering, we'll see one of them. Okay, tell you what information we got is that discovery through observation. You see these lines, what we see, how the stars and other galactic objects have been detected through the telescope. You know, when they are moved, red shifted and blue shifted. Blue shifted means towards higher frequency and lower wavelength. Red shifted means higher wavelengths and lower frequency. Unshifted, see, they have gone this side, they have gone this side. This is so these spectral lines we observe, the light emitted by the stars. If they are moving, so if they are blue shifted, then we say that it is coming towards us, and red shifted if they are going. So that is how people found out. So as I told, these atomic emission light or absorption lines are the fingerprint of all the elements. They are the fingerprints. That is how we make use of the spectroscopy. These are atomic absorption lines, and there are tremendous, the advances in this. Sorry, I forgot to speak in Telugu, but definitely I know most of our students, they're all now equipped with a good English, they will understand. And so coming to the laser, how laser has transformed the photonics, the optics. So you all know that laser is light amplification by stimulated emission of radiation. So the light is emitted generally through a process called stimulated emission. As I told, we excite atom molecule. That means that the electron orbiting around the atom is excited to the higher energy levels, and it stays for a short period and decays back. So that is called the time retained there, the lifetime, and decays back by emitting the light with the wavelength difference of that two energy levels, E is equal to hc by lambda. So that is called all incandescent light. So it is the light which we are very familiar, all the tube lights, all the fluorescent lights, and all the sunlight, everything, moonlight, everything is incandescent. But the laser is not incandescent, it's a coherent light source. Laser is a device that creates and amplifies narrow, intense beam of coherent light, having some spectacular properties. What are the properties? Definitely, it is when it is a coherent, and when it is a directional, when it is bright, and when it is a polarized. So directed, highly directional. That means that it has a very low divergence, whereas incoherent light diverges. It won't go more than a few meters, right? We see daily in the house. But definitely lasers can be passed through even moon or beyond. That is how, small laser. In fact, I do have this laser, and this, of course, it's difficult to show. They are used very small power lasers to find out the distance between Earth and Moon. And, we can make use of these lasers to study at very long, ranges, various things. One of them is laser range finder. See, you want to find out the enemy's aircraft, which is, let us say, 200 kilometers. Still, you can find out whether it is coming towards us or what is the distance. If you want to neutralize, you want to, kill it, we must know the distance. So the range, what is the range at which your target is? So lasers, pulse lasers are there. So just to a couple of transparencies on the lasers, how laser is made. You need active medium. That means it can be atomic source or the plasma ion source. You need active medium which will amplify it. And then you must excite, as I said, you must excite this active source. So through discharge or through chemical means, chemical lasers, or electrical lasers means, so you have to use a discharge. So those are gas lasers. helium neon, argon ion, krypton ion, so many CO2 lasers, all those ones. And then this excited medium is kept in a resonator, is a cavity for feedback. That means that the light which is excited, the atoms which are excited, or the electrons in atoms or molecules excited, when they decay back, they, as I told, it will emit a photon. But we excite them such a way that more number of atoms or molecules are there in higher energy levels than the lower energy levels, which is contrary to the nature. Nature always keeps everything in low energy state, right? So it is a stability. So low energy, low potential energy, low kinetic energy. So all the molecules, when it is kept at a certain temperature, even at 0 Kelvin, obviously everything supposed to be in the ground state. Otherwise, at some little lower to little vibration, higher vibration state. So when we excite them, many, strongly, certain medium, so the certain atomic sources, for example, I should say helium neon, and I should say erbium doped fibers, erbium laser, all these ones. So you have population inversion. That means more electrons are in the atoms. So electronics excited means atomic excited. So they are in the higher energy stored, more of them. So we say that higher population and lower population compared to the lower. Then the first molecule which emits or decays through spontaneous process will trigger all the atoms or molecules which are excited in the higher energy state, and thereby all of them come back, and then they travel back and forth because two mirrors are kept here. Plano mirrors are, you can have the concave mirrors, and it will go through and further excite. All of them emit in at the same time coherently. That is how you get a coherent beam of light. So one mirror is 100% reflectivity, another is partially reflected, so that at certain dynamics, and the light start transmitting through the partially reflected, and you will get a laser with a very special characteristics. Okay, what are the characteristics? Highly bright or high intense lasers. So they are from microwatt to, these days you can get terawatt, even beyond that, terawatt. That means 10 to the power of 9 gigawatt, terawatt, 12. 10 to the power of 12 watts, you can get it. And they are such a bright ones. So what we see, many of them milliwatt. And for let's say biophotonics, we use even small, several milliwatt is good enough. Highly monochromatic, that means single color, and single wavelengths. Sometimes they are called single mode lasers, but many of them will have very small bandwidth or line width, we call. They are quite monochromatic. They are green. So highly coherent. That means all the molecules are triggered by the first photon, so that all are decayed back from upper state to lower state, emitting photons in coherent. So all of them in phase, spatially and temporally, in time and space because we have a cavity. So they all go back and forth in the same direction and come out, so that they are spatially coherent, and same time they are emitted because they are temporally coherent. These two factors are exploited for developing various technologies and various systems. We'll see. Then highly directional because of the cavity. So low divergence. That means they can micro radiance. That means I can send small laser, 5 milliwatt laser to moon without diverging it beyond, let us say, 500 meters or even 1 kilometer. Any other things like LED or any other things will not be able to go. It will diverge so much. And they are polarized. You can make them polarized. These days, you can make spin angular momentum or orbital angular momentum. Both are associated with these highly polarized laser beams. So these properties also exploited very much in developing various gadgets or various technology. And these days, wavelength tunable. So wavelength can be tunable from over 1,000 nanometers. Such lasers are also there. Generally, they are not tunable, but you can make using by adding, let's say, diffraction spectrometer. What is that? Grating. Or other means. There are other birefringent medium. You can do that. So, and they are CW. That means, like in electronics, we say DC and let us say AC. So DC means CW. Continuously. They're short pulse. They're all pulse one. So, of course, you can call them DC pulses. It's not AC. Highly modulated frequency. So in communication, you see, we are using these light sources, whether LED those days, afterwards we super luminescent laser diodes, and these days we use erbium doped lasers and fiber lasers, which I am supposed to be expert in that. And we use these lasers for modulating to very high frequencies. That means information encoding and multiplexing and demultiplexing and decoding, everything. So these modulating lasers by various optical modulators are there. So even you can do the amplitude modulation, frequency modulation, all kind of modulations. So for telecommunication, in fact, it is very much required. So all these properties are very innate of these lasers, and we exploit different properties for developing different. So this is very important. So just as I told, how the atoms and they go from ground state to here, and they fall to intermediate state here, as you see. Then all of them will decay. First, one photon will. They all will be in coherent. So this is how laser is done. Of course, I can take a lot of questions in this. Oh, and these lasers are available in all kind of materials. As I said, solid state lasers, gas laser, ion laser, excimer molecules are there, metal vapor lasers, dye lasers, synthetic dyes, and semiconductor diode lasers. Very important these days. And all that you see these what do you call what do you call pen drive, not pen drives, pointers are made out of semiconductors. And fiber lasers, as I said, these are the new types of lasers. So optical fibers are not only used for transmitting the light, whatever information coded light, will give you both analog and digital also. Digital signals can be, light signals can be passed, and then later on, they can be extracted, the information. But similar fibers, but they are doped with some rare earth matter, rare earth atoms, ions basically. They turn out to be good laser materials, and since it has got a lot many better properties than conventional lasers, these days it has become a prime laser source for industry also. All material processing, cutting, welding, drilling done using lasers, these fiber lasers. Earlier, they used to done little with the CO2 laser, and now they have become prime candidates for DEW, the directed energy weapons. So DRD is also engaged. I was also party. Even now, I am helping certain groups. So to develop a quite new type of weapon systems, directed energy, laser-based directed energy weapons to transmit very high power lasers and destroy some low-flying objects like rocket shells, UAVs, drones. So, as you remember, last Republic Day, DRDO demonstrated some, a sort of DW, low power DW system, which can be used up to 1.5 kilometers to destroy UAVs. So, but we got to, go much into it and develop hundreds of kilowatt laser. With 10 kilowatt, we can go up to, for example, 1.5 kilometer range to kill, to structurally damage system. Unlike, of course, another DW source is their microwave, high power microwave directed energy weapon. That is equally important. Rather, it is better for neutralizing this form of, let us say, the UAVs or drones. The entire battlefield scenario will change, the paradigm shift because of these, what is the invention of these drones. Let us form of drones, maybe 2,000 drones will come from all angles to attack some target. Let us say how to kill them. Obviously, you can't kill them. Laser can kill some 100 but then you can't kill all of them. They all carry some explosives, and they all are intelligent. They all have the eyes in terms of digital cameras, and then small imaging systems. So how to kill them? We use microwave to disrupt their electronics, disrupt their electronics, and then they will all be blind, and their electronics will not be working, and they can be neutralized. That is one of the, so all the countries are working, and India is also working. That means developing a microwave, high energy microwaves, high energy lasers are very important these days to develop directed energy weapon systems. This is unconventional weapon. Otherwise, we have missiles. So kinetic energy weapons. So ultimately, they are required, but this new kind of direct energy weapons is in addition to the battlefield. Okay, so they are pulsed, they are quasi-pulsed, Q-switched, they are nanosecond. They work only up tack. So nanoseconds. So we use them for detecting picosecond, mode locked. There is another phenomena, another technique we use to convert the CW lasers into picosecond, femtosecond, attosecond. So 10 to the power of -18 seconds only it will emit, but it will be terawatts, even beyond that. So that short pulse. So these lasers can also be used in research, particularly let's say chemistry or biology, where we want to study the transient state of these molecules. Many of them are biological molecules. So you can study at that time states how reactions are taking place. So breaking bond and making bonds, they call. So they use femtosecond lasers, picosecond lasers, nowadays attosecond lasers to study these transient phenomena that occurs in energy transfer reactions in biology and in chemistry. Okay. So without going much into this one, see the plenty of applications in defense itself. So, for example, laser rangefinders, I said laser target designators. So we designate using a laser, and then weapon will home on to the target. So that means it's a guiding. So laser beam riding or guidance and navigation applications. Laser seekers for LGB, laser guided bombs. You know, the Kargil and all that. You know that when the enemy soldiers are hiding in the bunkers, how to kill them. So you needed a point targeted, the weapon should go and do that. So you need to illuminate, or we call it designate with one laser onto that, either from the airborne platform, and with another bomb will follow that route and then fall on that and destroy that. So that was the very important weapon. And that time we borrowed from Israel, but these days we developed. LiDAR seekers, ATR, terminal guidance. These are all these days, all weapons are smart. They have become we called seekers. That means they have eyes and they see towards the end. If it is a long range weapons, let's say our Agni weapon, so it will see the seeker, or some of them will not have, but these ones are Prithvi, they're seekers, and they search for the target and home on to that and deliver the payload, that is the bomb explodes there. Spot detectors, inertial navigation, ring laser gyroscopes, proximity fuses. So it will go to the target, but let us say just before target it should explode. Then you need to know that. And reconnaissance, warfare agents, explosive mines, laser free space communication. That means that our usual electronic communication is can be easily jammed. So of course anti-jammers are there. That is electronic warfare, we call it. But then you can have sometimes a strategy for a strategic communications. You have free space. That means there is a transmitter and then receiver somewhere, and through space beam goes and provides the information or energy. The information transfer. Then guidance. All the rifles will have illumination, dazzling, anti-sensor application, jamming, missile security. The last one is, which I told, laser directed energy weapon, which I told these are the weapons. Actually, you need a laser with very Gaussian type of spot. All lasers are not. The other lasers, we call TAM00, the electronics persons in the microwave, how the field distribution is noted with this kind of modes, TM00 mode, transverse electromagnetic field distribution. So we need this kind of one which can be easily focused, and whereas this one will be little difficult and this one will be little difficult to do. So, but these little less, let's say the multi-mode lasers can be used for drilling, for all other applications. So, but you want to transmit some laser over tens of or thousands of kilometers, you need TM00. So that means that for our directed energy weapons, you need a TM00 mode, we call Gaussian mode lasers. So that kind of lasers are required so that the laser energy, electromagnetic laser is nothing but a beam of electromagnetic radiation. So it is transferred, focused onto the target so that efficiently, so that it is melted and exploded. Okay, so these are the first kind of lasers, the crystal lasers, the ruby lasers. It was the first laser invented in 1960, and since then there are a number of lasers within a span of a few years. This is the organ solid state laser. These happen to be workhorse defense, particularly range finding and other applications. Of course, even in medicine, it was being used till some time back. Now fiber laser has taken place, CO2 laser has taken. So wavelengths are important when you are handling in the biology, when you are handling biological samples. So we'll discuss, this is the diode lasers. We all know, see, many of you must be from electronics background. You all know how a diode, an LED works. Just to show you how an LED works, you see, I'm just first small experiment which I'm demonstrating. You see, I have a DC motor, small 15 rupees DC motor. I'm holding it, and then I have connected to a small electronics DC voltage booster, right? I can also make by, Joule thief circuit these days you can call. That means that very low powered, even 1.5 volt can be amplified to several kilovolts, isn't it? So many of the electron specialists, those who are studying in the electronics communication, electrical, they must be knowing voltage booster circuits. So these days, these are easily available. So instead of making one, of course, I demonstrate to the students the one which I make. You see, what I am just rotating this, and the LED is glowing. I connected an LED to the output. There is no battery in this. This is nothing but a electric generator, isn't it? So this is one experiment I show when I visit school children, sometimes engineering students as well. They showed a lot of interest how you can power an LED to light up. That means it requires definitely 2 volts, 1.85. But then if you use even 10 mm LED, I will show you, and you need 3 volts. So since this is a small motor, so how it is being done, you all know. You all know that Faraday law, how DC motor works, how AC motor works. So there is a magnet and there is a rotor in terms of a coil, and I'm just rotating, and then the magnets are, these are permanent magnets are steady stator, and then the coil is rotor. I'm just rotating that coil. So whenever a coil of let us say copper is rotated through a magnetic field, it intercepts the magnetic field. The change in the magnetic field will induce electromotive force, EMF, in the coil. So that is what converted as a voltage, small voltage. I'm amplifying it. I'm able to see this one. Okay. So another one, without wasting time. Yeah. So you guys must be seeing this. I'm not. So I'm just going to blow air. So same thing, instead of rotating with the hand, I'm just blowing this fan, small fan connected to the axis of this DC motor, small DC motor, which cost something like 20, 30, 40 rupees, and then connect through this voltage boost generator, DC, and this is what your windmill works, how this windmill works. So basically, here we are demonstrating. Why I'm saying is this LED, these LEDs, you all know that you see in different illumination circuits, and this is nothing but a cousin of laser diode. See, laser diode involves in the stimulated emission, whereas the LED involves in the spontaneous emission. That is why the stimulated emission, and then of course the construction of the laser diode such a way that the confinement of the photons emitted between two semiconductor bands. Of course, these are different semiconductor, doped semiconductor. Unfortunately, these are not silicon or germanium, but these should be, let us say, aluminum gallium nitride, gallium arsenide, this kind of hybrid compound semiconductors, because they're all direct band gap semiconductors. The efficiency of emission of excited electrons with holes in the valence band, and then recombination of this will emit light. And this light is confined using a sort of wave guide, so that this is amplified further using same formula, same process called what is that, stimulated amplification. So this laser happens to be, and this laser, what happened, is used to pump or to excite another lasers. So fiber laser, this is very important. Diode lasers. Diode lasers are very important, and they are further. Why we can't use a diode laser? So here, fiber laser. What is that fiber laser? You have a fiber. Actually, this can be we used, for example, to develop 1 kilowatt of fiber laser. We take fiber, let's say 2400. That means the core diameter is 20 nanometer, and whereas the clad, so the optical fiber, we know that it is surrounded. The core is surrounded by the clad, which has got higher what is that, the refractive index. So this is a double clad fiber. Let us say we use 16 meter, just for principle sake, how it works. We use a diode laser, and the light emitted by that, we focus into the core or the first clad of the this fiber, and which is doped with, let's say here, some rare earth ion, here ytterbium doped fiber. And then this 975 nanometer laser diode is sent through this, and you know that the internal total reflection takes place. We know that light is passed through space only in a straight line. You can't bend it unless otherwise some waveguide is there. So optical fiber is nothing but a optical waveguide. Even it is made round and into a spool, or that is how our internet signals, our communication signal for the internet, they are laid through oceans, underneath even seas. How many countries whole world is covering. So our light signals are passing through this mechanism called total internal reflection. And so here what happens, this light is observed by the ions doped in the core of this. So, and that will emit light, and that will, is converted into different wavelengths, 1070. But this is a laser, whereas this is a band laser. Diode laser is a little band laser. That means it is multi-mode laser, but we need a single mode laser. Gaussian profile should be there, so that it can be transferred, or it can be used for drilling holes very precisely. So this kind of thing is used. So this is the mechanism for developing fiber laser, which is the latest. This is the, you can say, what do you call, you can call, and say, in fact, not able to remember, destructive technology. Destructive, that means it destroyed all the erstwhile technologies, earlier technologies, because it has got better. So of course I'll not go into the laser. Sometimes when we discuss only lasers, but so many processes are required, because fiber laser is a laser which is monolithically connected with all diodes and combiners reflectors we call Bragg reflectors, fiber Bragg gratings, and then actual laser medium, this the blue one, and then you have a collimator or fiber delivery system where so like that you can get laser several kilowatt. The 10 kilowatt or 20 kilowatt laser power can be transmitted to just let us say 20 nanometer core of the fiber, right? So sorry, it is 20 micron core of the laser. So these days we use amplifiers also. So this is let us say 1 kilowatt laser, which my own group developed. So this is the actually this fiber laser is being the research on fiber lasers is done by electrical engineers these days, mostly elsewhere in Europe and US. Electrical, even in IIT Madras and other people. These days, the less physics people, more of, because it involves a lot of electronics, but then what happens, you know, this is a waveguide. So these guys, the electrical guys, they thought microwave waveguides, and this is also, photonic waveguide or optical waveguide. So they do a lot of research and PhDs, and IIT Madras has got a very strong group led by Professor Balaji, and there is thousands of crore budget is available for developing high power fiber lasers for defense applications, but no takers. But we, the DRDO, still developing some industry. One in Cochin, they are doing quite well so far. We developed to 2 kilowatt, and through industry we developed to 3 kilowatt. Then we got to combine them such a way that coherent beam is generated up with energies in excess of 100 kilo. So there is a lot of money available, but we sometimes buy them from outside. 10 kilowatt system, only few companies are able to sell, and then we combine them. But our lasers are now being combined for generating high power lasers for DW. But we used several this kind of lasers to generate a system which can neutralize let's say drones up to 1.5 kilo. This is how, when you are doing experiments with our fiber, this is 16 meter doped fiber, and you can see this is just outside. We are yet to assemble this one in the lab. Just I'll go through this. These are all laser diodes for assembly. These are all laser diodes. It requires cooling also, and these laser diodes, the light passing through the fiber is spliced with the erbium doped fiber. All these are spliced. That is why fiber laser monolithically like electronic chip. So it is one laser. You don't need any bulk systems, alignment, anything. So it is lightweight and then monolithically stable and with good beam size. Okay. So this just for some photographs. You can see this is a 1 kilowatt system. This is a 2 kilowatt system. This is the first 1 kilowatt system, and several. This is the amplifier. So how to amplify? You generate some oscillator. That means laser is nothing but an oscillator, with a positive feedback, so that back and forth this light passes through the resonator and comes out of this 1.5 kilo, 8 kilowatt with this one. Then use the small oscillator and then amplifier stages to generate more. But there is a limit. Because other unwanted noise signals will come and they hamper the amplification. Okay, just so you see, this is not ours, but you can see this is a 20 kilowatt system, single mode, and this is also 2 kilowatt system. This is a bulk. And these are all 10 kilowatt system. There is one company called IPG Photonics. They are the leaders in the world. they're not able to meet the requirements of even US defense. So it is very thing is industries. So you want to, you want to destroy something in defense using lasers. You need hundreds of kilowatt. Kilowatt is good enough up to some 100 kilowatt UAVs, not 100 kilometers, but maybe 10-20 kilometers, and then 10 kilowatt neutralization of buried. You can also destroy the buried mines. 1 kilowatt surface mines. Then you need rocket shells, artillery motors, all these one. You need beyond 10 kilowatt. You need 100 of kilowatt. Then you need megawatts of system for ICBMs, ballistic missiles. So you want to replace them, you need that kind of thing. So people are trying to develop, but meanwhile, people are trying to use as anti-satellite, ASAT, against a satellite, because tomorrow we will not be knowing if there is a battle, if there is a war between two developed countries, there can be war on our satellites also. So to protect, we must have some what do you call high-powered lasers stationed in that, so that it serves as a defense for that. So that is also there. Okay, I'm not going into the formulae how the laser is focused to that one. We got to remove, when we are transmitting through atmosphere, we got to compensate for the atmospheric turbulence, because atmospheric turbulence will spoil the coherence of the laser beam, and then it will not be able to focus properly. So we got to compensate. Something is called adaptive optics. So we use adaptive optics to correct the beam and then focus it. So this is a standard equation if you want to develop any laser system. What kind of wavelength should be there, what kind of brightness should be there, what kind of transmitting telescope should be there, what is the range, then what is the atmospheric transmission losses, telescope losses, and then ultimately turbulence losses. And then tracking, focusing, pointing, tracking, focusing, all these technologies are required. So I think I'll not go much into that, but you see how lasers these days are used for material processing. These days, lathe machines and milling machines. Yeah. 5 minutes ago. Okay. So you can use, you can see the, the processed structures very precisely with lasers, as I said. So in defense, people want to put them on board in the air platforms and attack the ground systems from the air. And people also want to use in space also. This is what happening. So what is the main advantage? These weapons, the speed of weapons would be at the speed of light. So it is long ranges. So that is one of the main reason people want to go for laser beam weapons. Another thing, when it comes to research, we make use of one property of light, which I told, interference. See, interferometers you can develop to study the small variations in the thickness or in the morphology. We can make use these interferometers. Very easy to do that. I did it in my house also. Maybe some other time we can show. Basically, you need a laser and a beam splitter and a mirror. Another is a moving mirror. It is same principle what a FTIR uses. FTIR is nothing but a Michelson spectrometer with a moving arm, and a sample will be put here so that the light is observed. When it's observed, the fringes formed will be different, and then we convert them, Fourier transform them to get the spectra Otherwise, it will be in the frequency domain. The rings will be converted into the spectra. For example, LIGO interferometer. Recently, you know that our means the international scientists said they discovered the gravitational waves. So it is one interferometer. There is a huge path length. Then they can study small ripple in the space time. You know, you want to study the general theory of relativity, how gravity works some other time, how the entire cosmology. So everything is understood. We know that four fundamental forces: gravitation, electromagnetic force, and you have strong nuclear force, short nuclear force. But we know very well about the gravity. But that is all classical gravity. Really, we do not know much how it works at a quantum level. So that is called gravitational. So people wanted to find out, are there gravitational waves? So recently they detected, in fact, Einstein suggested, recently detected using this infrared. So this is also used for, ring laser gyroscopes, navigation for missiles. They will be developed like this. So various ring laser, we used something like Sagnac effect. There's also interferometer, but they couple and interfere, and the small changes in rotation, very, very small rotation, it will identify, it will give the good shift in the laser frequency or phase difference. Then phase is converted into electrical signal. So these are all there. You can detect Doppler velocity. You can find out the velocity of the various particulates. Holography, you know that, how 3D lasers. How, I told these laser beams have momentum. Using momentum, they can transfer, they can move, or they can rotate, they can squeeze things, because that is longitude, the orbital angular momentum recently used for manipulating the nanoparticles. So in biology, it is very much a big field. Raman, you all know that how Raman system is developed even before the invention of laser. But the laser invention, gave impetus to this, because it is a bright laser source. Developed this one, how the vibrational frequency of molecules is detected using Raman. Since there is less time I'm going through, so the laser will be shined on the molecule, and then you will get not only the emitted line, not only at the same frequency, but red shifted and blue shifted, Stokes and anti-Stokes. And these Stokes is much stronger. We use, and these shifts will tell you about the vibrational frequency, vibrational modes of various molecules. They are fingerprints. That is why we can find out using these molecules, you see how they are. So nothing in the world is at static. We all know that everything is vibrating, and these molecules are also vibrating. They will have vibrational modes, and Raman spectroscopy determines them. And in biology also, we use various Raman microscopy to detect label-free detection of brain tumors with stimulated Raman scattering microscopy. So this is our first, developed first equipment of Raman, and subsequently we developed many other variants, and some of them have been passed on to our IB, these systems, and these are all Raman, indigenously developed Raman systems. So it will provide, and people whoever want to see this can visit Hyderabad. I will demonstrate them, and they can bring any material, chemical, and we can identify them. At 5 meters, you keep it, and it will detect. So these are all, I will not be able. So these are all Raman signals of explosives. Spectroscopy, LIDAR, LiDAR or LiDAR, you can find out. This system is also getting developed in Hyderabad at Anant Technologies. We can show anyone, if someone comes, how to detect the height of the cloud. Immediately within a few seconds, we can detect the up to few layers we can detect. Up to 10 kilometers, whatever the cloud layers are there, we can detect. So light goes and hits the clouds, and then scattering, some scattering happens, and we detect using telescope, and then process that telescope. Then we can easily find out what is the
Hello.
Yes, sir. So coming to end, these are the
Excuse me, sir, Mata garu, ide lunch.
Yeah, we are closing, sir. We are closing it. Yeah.
We are closing it.
Yeah.
1 minute.
Yeah.
Yeah. So just wanted to show some of the the signals, but just wanted to tell how fiber optics sensors can be developed, even buried sensors, to find out any trespasser are there. So in defense, it is going to be very useful. These systems are being developed. So how then in communication, as I already told, how lasers are being used, even WDM and wavelength division multiplexing, dense wavelengths. And then other one is that these days, pilotless car, autonomous ground vehicles, how LiDAR is used to detect the obstacles you are them. Okay. Biophotonics, we all know that how imaging, biometrics, therapeutics, detection, surgery, how all this being done using this is a big area. I think we should dedicate one lecture only for biophotonics, and then silicon photonics some other time. Okay. Now that silicon photonics we are using to replace some of the electronics in the let's say processor by the silicon by photonic circuits, thereby increasing the speed of the what do you call processors, terabits. So a lot of research is happening, hybrid silicon. Okay, so Intel and all these people are engaged in this. So many applications of photonics are there, but maybe I should have organized a little better. Thank you.
So thank you very much for your nice and excellent presentation. Of course, we have a lot of information to share to the students. Now, sir, so it's anyhow, it's a lunch time. I don't think that they are going to ask the questions now. So, sir, can you propose the vote of thanks from your side? Or any 1 or 2 questions otherwise? Dr. Venkat Garu. Hello. Sir. Now it's over and somebody should press the vote of, yeah.
I have the pleasure of proposing vote of thanks. It's a great honor to hear the lecture of Marthan sir. It's been such a great detail. I do not think any textbook would cover this kind of practical, research-oriented knowledge. Thank you very much, Martha sir. I'm so grateful.
Thank you very much.
And also the scope program organizer, Professor Lakshmana Reddy Garu. I am fortunate that I am in this, and our institution is highly inspired to associate with NIT Warangal, and also Chandra Garu, who has been kind enough to be on board, and several professors and senior professors, NIT Warangal students, faculty, administrators. We all thank you so much. It's been a wonderful, inspiring session. We'll look forward for many more sessions, and we highly appreciate in the rural areas where we live, in the far and wide of the country, the biggest service today is happening under the scope. And we are proud that NIT Warangal, through Professor Lakshmana Reddy Garu and eminent scientists like Marthan Garu, we are able to take forward this mission, and we will increasingly participate, especially from the rural areas. We participate in a big way and spread the science and technology. Thank you very much. All the
Thank you.
best.
Yeah, yeah.
Thank you.
Yes, sir. Thank you. Thank you. We are also thankful to you, sir, for providing the opportunity to interact with your students. And sure, definitely we will have some more programs like this in future also. So, and it is our motive to help the student community. Thank you very much. Now I request all you to stand for national anthem.
National anthem.
Yes.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Thank you.
Thank you very much, sir. We are closing, Dr. Martha Andretti garu.
Yeah. So I should really thank Dr. Barla, Director Economics, and in fact, to have very good institution he is heading, and I'll be happy even to visit and show some of the experiments what I have made with in the house, and sometimes I carry them. Carry them to NIT Warangal or some conferences which they are doing it, but definitely this institution I will be very happy to interact with the faculty and the students over there.
Yeah, sure, sir. Sure, definitely. Whenever there is opportunity, we will take to the institute and so that we will show the demonstration. Okay. Thank you. Thank you very much.
Thank you.
Closing it. Yeah.
Bye everybody.
Bye.
నేను భోజనం వచ్చిన తర్వాత నేను అనౌన్స్ చేశాడు.